The final theory. What if I told you that everything you see around you, the stars, the planets, the atoms in your body, even time itself, might be explained by a single, elegant theory, a theory that brings together the deepest mysteries of the universe into one unified understanding? For centuries, scientists have been chasing this idea. They call it the theory of everything, some call it the final theory, and if we ever find it, it could change everything. But before we go deeper, let's pause for a moment. Why do we even need a final theory? Right now, science relies on two powerful, but separate theories. First, we have general relativity, Einstein's masterpiece. It explains how gravity works, how planets orbit stars, how galaxies bend space and time. It's our go-to theory for the very big stars, black holes, the expanding universe. Then we have quantum mechanics, the bizarre mind-bending science of the very small. This is the world of atoms and subatomic particles, where particles pop in and out of existence, and everything is ruled by probabilities, not certainties. Both theories are brilliant. Both are backed by decades of experiments. But here's the problem. They don't work together. Try using quantum mechanics to explain black holes, or use general relativity at the center of the Big Bang, and the math just breaks. It's like trying to fit two puzzle pieces together that just weren't made for each other. This is where the final theory comes in. The goal is simple. Find one theory that combines gravity and quantum mechanics into a single framework, a theory that works for everything from the tiniest particles to the largest galaxies. It would be the ultimate explanation, the final word on how the universe operates. Einstein spent the last 30 years of his life chasing this idea. Even after changing our understanding of time and space forever, he couldn't stop thinking about something deeper, a deeper harmony, hidden beneath the surface of all known laws. He died without finding it. But others picked up where he left off. Some of the brightest minds in physics believe the answer lies in something called string theory. Instead of particles being tiny points, like dots, string theory says everything is made of tiny vibrating strings of energy. The way these strings vibrate determines whether they become an electron, a photon, or something else entirely. It's a beautiful idea. In fact, it's so mathematically rich that it automatically includes gravity, something no other quantum theory has managed to do. But here's the catch. We can't test it. At least not yet. The strings are too small, much smaller than anything we can detect with current technology. So while string theory is elegant, it remains just that, a theory, waiting for evidence. There are other candidates too. Loop quantum gravity suggests that space itself is made of tiny, discrete loops, like the pixels of a video, but for the fabric of reality. Others have proposed ideas like emergent gravity, causal sets, and holographic principles. But none of them have been proven, not one. So why do physicists keep chasing this elusive final theory? Because the universe is whispering hints that something deeper lies beneath it all. Every time we discover a new particle, a new symmetry, or a strange cosmic behavior, it feels like a piece of a larger puzzle. It's like seeing shadows on a wall and knowing there is something casting them, something just out of sight. Historically, science has always moved toward unification. Newton unified the motion of the heavens and the earth with his laws of gravity. Maxwell unified electricity and magnetism into a single force, electromagnetism. Einstein showed that space and time are not separate, but one space-time fabric. Each time we've unified something, we've discovered deeper truths and unlocked new possibilities. So imagine what could happen if we found the ultimate unification. A theory that tells us how the universe began, what happens inside black holes, what dark matter really is, why the constants of nature are exactly what they are, and not slightly different. A final theory could explain it all. But let's be honest, the road is hard, the math is brutal, the ideas are abstract, and sometimes physicists go years, decades even, without a major breakthrough. Worse, some argue that the theory of everything might not exist at all. Maybe the universe just doesn't follow one single rulebook. Maybe it has a patchwork of different laws that happen to work well together. But don't they come from a deeper foundation? That's the big philosophical debate. Is nature fundamentally unified, or just incredibly lucky? Some physicists worry that we're chasing a dream that might never come true. Others say we're asking the wrong questions, or looking in the wrong places. After all, science is based on experiments, and until we can test these theories in colliders, in space, or through precision measurements, we're just guessing, no matter how beautiful the math may be. Still, the pursuit continues. Every year, new theories emerge. New observations from telescopes and particle detectors offer tiny clues. We're mapping gravitational waves, peering into black holes, studying the cosmic microwave background, the afterglow of the Big Bang for tiny anomalies that might reveal deeper laws. And maybe, just maybe, we're getting closer. What would it mean if we finally succeeded? Imagine holding a single equation in your hand, short, elegant, yet powerful enough to describe everything. Not just how things move, but why they move, why time flows the way it does, why matter exists, why the universe even has laws to begin with. It would be the greatest scientific discovery of all time, not just for physics, for all of humanity. But even if we never find it, the journey itself is worth everything. Because the pursuit of the final theory isn't just about equations and particles. It's about curiosity. It's about asking the biggest questions. It's about that human urge to understand where we came from, how everything works, and what our place in the universe truly is. Every generation has looked up at the stars and wondered. We've built telescopes, launched satellites, created massive machines to smash atoms, all in the hope of finding answers. The final theory is just the next step in that journey. So maybe the real power of this theory isn't in solving the universe, but in reminding us that we're still explorers, that there's still mystery, still wonder, still something greater waiting to be discovered. And maybe, just maybe, one day, someone will write it on a chalkboard, a single equation that changes everything. Until then, we keep searching. Thanks for watching. If this made you think even a little differently about the universe, consider subscribing. There's so much more to explore together. From black holes and time travel, to the edge of the observable universe, because the universe is vast, but our curiosity is even bigger. Stay curious, and I'll see you in the next one.